Hi, how are you all? You know something? When we get heat, okay, the volume expands. Or when we give heat, then the volume reduces. I'll give you an example. Say, sometimes we say like in summer season, oh, it's so hot. It's so hot, see. So the volume is increased. And in winter season, oh, so thanda it is. So the volume is reduced. I know this is a funny example, but that is true. For any material, say iron, copper, aluminium, any material, when you give heat to it, the volume expands, volume increases. Okay, and when you taking out heat means you are cooling it. Okay, you are cooling it. When you are cooling it, the volume reduces. Okay, now we'll do some experiments that will show the size of the material is really increasing or really decreasing. Okay, we'll do some experiments on that. But before that, I want to give you another idea. Say I am taking a simple rod, okay, a metal rod I have taken. A metal rod. Now, if you give heat to it, the area of this metal rod will increase. Okay, sorry, the length of the metal rod will increase. Okay, so when the length is increasing, we call it linear expansion. Understood? Linear expansion. And say, can you see this plate? Say this is a metal plate. Okay, this is a copper plate. Understood? So it has got an area. Okay, this is the area. Now if you give heat to it, the area will be increased. Understood? The area will be increased. That is called superficial expansion. First one was linear expansion. The length of the material, length of the rod increased. So this is linear expansion. And when the area increases, then it is superficial expansion. I will give you another, say I don't have any other object now. Or say if I take this bottle, okay, if I take this bottle, can you see this bottle? This bottle, it has got a volume, a fixed volume it has. Okay, say the volume is say 2 liter. Okay, 2 liter is the volume. Now if you give heat to it, the volume will increase. The volume will increase. Understood? That is called cubical expansion. So when the length is increasing, linear expansion. When the area is increasing, superficial expansion. When the volume is increasing, cubical expansion. Got it? Now we'll see, as I told you, that we'll do some experiment to show the linear expansion, superficial expansion and cubical expansion. Ready? Let's see. For that, the first experiment, for that I will take a small rod. Okay, this is the rod. Okay, which I have fixed here. The rod is fixed here. Okay, it's fixed here. Now, here a needle is there. Okay, a needle is there, and here is a scale. This is a scale. This is the needle and this is the scale. Okay, this is the scale. Now you have to give heat to it. Say we'll take a burner and we'll start giving heat to this rod. Okay, so this is the, I'm giving heat by using a burner. Okay, gas burner, you have to give heat to this rod. Okay, say you are giving heat for say 30 minutes. For 30 minutes continuously I am giving heat to it. And after 30 minutes you will notice that the needle, this needle is, say this needle is going this way. Why it is going this way? Because it is pushing. This rod is pushing this needle. Pushing this needle, and the needle is going like this. Okay? The rod is pushing it. Why the rod is pushing it? Because the length of the rod is increasing. Why the length of rod is increasing? Because of heating. So when you are giving heat to this rod, the length of the rod is increasing, and since the length of the rod is increasing, it is pushing this needle, and the needle is coming this direction. Okay, so this indicates that linear expansion took place, means the length of the rod increased. Okay, so any rod, whether it's a iron rod, copper rod, aluminium rod, any rod, if you give heat to it, the length increases. Now the question is that whether all the material like iron, copper, aluminium, all these three materials expands equally? No. All the metals do not expand equally. Okay, some metals expands more, some metals expands but less. For that, say I'm taking, say this is iron rod. Okay, this is an iron rod, and say this is a copper rod. This iron rod and copper rod I am taking together. Okay, together, and I am just holding it tightly. Okay, tightly I am holding it. Okay, by any special glue or by something you just tight. Okay, tightly. Now you give heat to both of them. Okay, you have to give heat to both of this. Understood? When you are giving heat to both of this, you will notice that the straight rod is starting bending. Yes, the rod was straight. Now you will notice that the rod is bending like this. Why the rod is bending like this? Because one rod is increasing more than other, and because of that, since both the rods are tightly attached, so that's why they are bending now, which indicates that the two rods made up of different materials are expanding in different amount. So that's why they are not straight now. After getting hit, they are bent like this. Okay, so different materials expansion is different. Okay, though you are giving equal hit, but their expansion, rate of expansion is different. Okay, this is called linear expansion. Now I will take a metal plate. Okay, a metal plate I am taking. Say this is the metal plate I have taken. Okay, now from this metal plate I will cut another metal plate. Okay, a square shaped metal plate I will cut. So this is the square shaped metal plate I am cutting. Okay, this one. Fine, metal shape, and I will take out this metal plate here. Okay, this one I have taken here. Understood? Now you start give heat to it. Okay, you give heat to it, say for 30 minutes, 1 hour, you give heat to it. Okay, after giving heat, then you take this metal plate and try to adjust here. You will not be able to adjust. Yes, this metal plate, though the size of this hole and the size of this metal plate are equal, because this metal plate we have taken out from here. Okay, but now after giving heat, you are not able to adjust this metal plate here, because the size of this metal plate is increased now. Okay, which will not be fitted here. That means area of the metal plate is increased. That is superficial. Yes, superficial expansion. Okay, now another experiment. I have taken a ring here. See, it's a ring. Okay, simple ring. and I'm taking a metal ball, say copper ball. Okay, the size of the ball I have taken, the size of the ball I am taking such way that the ball can just pass through this ring. Okay, this is the ring, understood? This is the ring and this is the ball. Okay, this is the metal ball. Metal ball which can just pass. Okay, I mean the size of the ball and the size of the ring are almost equal. So that the metal ball can pass through this ring. Okay, pass through this ring, this one. Now in this condition, I will take the ball and I will hit to it. Say for 1 hour, 2 hours, you are giving hit to it. After that, you will notice that if you try to pass the ball through that ring, you won't be able to. Yes, the ball will not go through this ring. But earlier, it was going through. But now, it is not going through this ring. It's not passing through this ring. Why? Because the volume of this ball is increased now. The volume of the ball is increased now. Yes, this is called cubical expansion. So we have done 3 experiments: linear expansion, superficial expansion and cubical expansion. Understood? Yes. So you must prepare these experiments for your exam or any other purpose. Okay. So we'll meet in the next video. Thank you all.